So this video is about solving a linear system algebraically. And we know that solving a system algebraically as opposed to graphically has many benefits. The first is if we were solving it graphically and the point of intersection happened to fall between a grid line, we would have difficulty reading the accurate answer. And second of all, if we just happen to be needing to solve a linear system and we don't happen to have graph paper with us or a graphing calculator, then algebraically is the way to go. So there's two different methods we're going to talk about. The first one is called substitution. And that's what this video is going to be about, is substitution. So let's start off with an example. So you remember, when we're solving, what we're trying to find is the point of intersection between two lines. So let's say I've been given two lines. I've been given x plus y is equal to 4. And I've been given the line 2x minus y is equal to 11. Now, two things I want to talk about here. First of all, most of the lines that we see when we graph them are in the form y equals mx plus b. These ones aren't in that form. We could rearrange them if we wanted to, if we were graphing. But in this case, we're not graphing, so we aren't going to rearrange it. The second thing I want to talk about is the point of intersection is the point where the x's from equation 1 equal the x from equation 2, and the y from equation 1 equals the y from equation 2. In other words, it's the point xy where that works for both equation 1 and equation 2. So let's get going on this so you can see what's happening. We're going to call this one equation 1 in red, and we're going to call this one equation 2 in purple. All right. Our first step for substitution is we need to isolate a variable. And when I isolate a variable, what that means is I want to get a variable all by itself. And you can choose to isolate either from equation 1 or equation 2, but here's some hints. You want to isolate a variable that doesn't have a coefficient in front of it. So this one doesn't have a coefficient, this y doesn't have a coefficient, this x has a 2 in front of it, so it's not one of the ones we want to isolate. And this has a negative 1 in front of it, so we don't want to isolate that. So let's go up to equation 1 and let's isolate x out of equation 1. So I'm going to write in red to represent equation 1. So let's bring this down here. And we're going to isolate x. So that means get x by itself. So I'm just going to rearrange the equation. So x is going to equal, and I'm taking this y and I'm going to move it through the kerchunker or to the other side. So it's now going to be written as 4 minus y. I subtracted y from both sides. So this is still equation 1. It just looks a little different. But here's the good stuff. Now that I've isolated the x, I can say x could also be written as 4 minus y. X is 4 minus y. This whole thing could also be written as x. And that becomes important for our next step. The next step is to sub one of the equations into the other. All right, so I'm going to take equation 1 and I'm going to sub it into equation 2. And this is how that is going to look. So equation 2 is usually written as 2x minus y equals 11. But according to this, x could also be written as 4 minus y. X is 4 minus y. So where I used to have an x in equation 2, we'll write in purple. So where I used to have an x, I'm now going to put my isolated value in there, 4 minus y, because that's just another way to write x. X is 4 minus y, 2x, 2 times 4 minus y, same thing. Don't forget this minus y, that's already up there, and equals 11. Now this step right here, the 1 into 2, this is communication marks. And that's important to tell me what you're doing so you don't confuse that little monkey again. So at this point, now we just do a regular grade 9 equation. The 2 multiplies through the brackets. So I get 2 times 4, which is 8. 2 times minus y, which is minus 2y. And don't forget this minus y here equals 11. And what we're trying to do right now is to get y by itself. We're trying to find out what is the y value for my point of intersection that these two meet at. So now it's going to be 8 minus 3y is equal to 11. I'm trying to get y by itself, so let's get rid of all the stuff around the y. I'm going to subtract 8 on both sides. So minus 3y is equal to 11, subtract 8. We keep going. Minus 3y is going to equal 11 subtract 8 is 3. And then I'm going to divide both sides by -3, divided by -3, and so y turns out to be -1. So therefore, what I have so far is that the point of intersection, or we could also write the solution, is something x and -1y. So let's go back and see if we can figure out where can we get that x from. Let's go back up here. Oh, look at this. I now know what y is. And I've isolated x here. X is saying all the x's are going to equal 4 minus whatever the y is. So now my next step is to sub that y equals 1 back into x equals 4 minus y. So watch this next step. So the next thing I'm going to do is I'm going to take what I just found here, y equals -1, and I'm going to sub that back into equation 1. And you can sub it back into the original equation 1 or the new one. The new equation 1, if you remember, or we can see it up here, the new equation 1 is x is equal to 4 minus y. So I'm going to sub it back into that one. It doesn't matter. You could sub it back into the original equation 1 too. Because I was working with equation 2, I have to sub back into equation 1 though. Okay, if I sub back into equation 2, I'm just going to get a big circle going on. And now what I'm going to do is I know that, hey, y is equal to -1. I don't have to call it y anymore. So I can put it into there. So x is going to equal 4 minus, don't forget that minus sign, and then the y gets replaced with -1. So we've got that double negative going on there, so x is equal to 4 plus 1, which of course means that x is equal to 5. So now that I figured out, let's erase this, because now I know that my point of intersection is going to be at 5, -1. I could have gotten that by graphing it, but this is a lot more accurate, and in case it landed on a grid line, this ensures that I get the accurate answer. Now, how do we know that that's true? So what we're going to do next is we're going to check. We're going to check our answer to make sure that it's true. And what I'm going to do is I have to check both in equation 1 and in equation 2. All right, so let's go back and just remind ourselves what equation 1 was. Equation 1 was x plus y equals 4. And equation 2 was 2x minus y equals 11. There we go. When I do my check, I need to isolate the left side and the right side from the original equation. So left side, right side, and I'm going to do that here too. Left side, right side. Oops, that's right side. Okay, so what was originally on the left-hand side here was x plus y. And what was originally on the right-hand side was 4. And notice I'm not putting equal 4 because I'm seeing whether when I sub in the values I got for x and y, it makes this true. Because if it doesn't make this true, I've made a mistake somewhere. If it makes it true, I know I've got the right answer. So now I'm going to sub in the point 5, -1, because that's the point of intersection that we found up there. So the 5 goes where the x was. The -1 goes where the y was. So it's 5 plus -1, and 5 plus -1 is equal to 5 minus 1, which is equal to 4. And so for this equation, the left side equals the right side, and that makes us happy because it works. But we need to double check it in both equations because there still could have been a mistake that we made somewhere. So again, we write the left-hand side of this equation, 2x minus y. The right-hand side is 11. Again, I'm going to sub in the points 5, -1, and it's going to sub into 2 times 5, so the x became a 5, minus the y became a negative 1. Make sure you get enough minus signs in there. There's the original 1 and then the 1 from the negative 1. And 2 times 5 is 10. That double negative makes it a plus, so 10 plus 1 is equal to 11. And again, my left side equals my right side, which makes us happy.